Hi guys. Welcome in iDrawlix 2k18, the first app for Mac OS X, which make you experience the art of sewering. In this webinar we will see how to run iDrawlix 2k18. As seen in our previous webinars, conduits and non-graphics drainage areas are linked one-to-one. Within the element drainage area, users are allowed to define the sanitary loads, the runoff spatial distribution, the amount of sanitary and storm pollutants. iDrawlix 2k18 produces after each sanitary run, a mean event concentration calculation in order to forecast both the mass balances and pollutant concentration balances of the sewerage. Within the window sanitary water quality, users are allowed to set the mass unit load per household per day. For every human activity, furthermore, it is possible to describe how each activity contributes, in terms of volume of water and BOD5, to the loads into the sewerage. Indeed, for each single drainage areas, users are allowed to set up the description of the overall human activities which characterizes that specific area, in order to let the iDrawlix 2k18 to account the real amount of sanitary pollutants which represent the input into the sewerage. Stormwater quality depends on the rainfall quality and, mainly, on the characteristics of the drainage areas. iDrawlix 2k18, after each storm or combined run, produces a mean event concentration calculation in order to forecast both the mass balances and pollutant concentration balances of the sewer network. For combined runs, particularly, both sanitary and storm pollutants are taken in account in order to produce such balances. Through the menu command Stormwater Quality, users are allowed to set, for each storm pollutant, the unit load per impervious hectare of drainage area per year that meanly contributes to pollute the wastewater carried by a sewer network. Within the window drainage areas, users can set the imperviousness of every single elementary area drained by each conduit of the network, in order to determine the correct rainfall as input for the rational method. Furthermore, iDrawlix 2k18 can consider up to 4 different rain models: the 2 parameters model, the hyperbolic 3 parameters, the ASCE 3 parameters, and the Deutsche Wetterdienst precipitations. In the current example, we consider the ASCE 3 parameters model setup as shown. If the command run combined is checked, then iDrawlix 2k18 will perform a combined run, otherwise it will perform just a stormwater run, pressing the menu command run stormwater. In the current example, we will run iDrawlix 2k18 in the combined mode. After the command run have been executed, we can verify the results of the model, as shown in the report window. This window is provided with a multi-tab view. In the first tab, take place a useful text area. Notice that such an area is fully editable. That we can choose the font family, the font size, the font color and so on. Sharing, for example, via email or iMessage, and copying text for any further paste into more sophisticated text editors such as Pages or Word is also allowed. A different and more compendious model results view is the tabular view. Notice that also within the above tabular view, we are allowed to select one, more or all the rows of the shown table, in order to eventually copy into the clipboard and then paste the current job into any spreadsheet such as Numbers or Excel. Focusing on the final revisioning activities, after each run, it is strongly recommended by various authors that the pipe gradient is able to ensure a minimum self-cleanizing velocity 0.7 meters per second. Higher velocities may be imposed for larger pipes according with the best practices of some engineer. It is, also, strongly recommended by various authors that the rate Y on H should be less than or equal to 70 to 75%. The smallest diameter for storm and combined sewer should be at least equal to a DN 300. The maximum flow velocity should be less than or equal to 6 to 8 meters per second. The pipe diameter must not become smaller downstream. As we can easily perceive, the column of the maximum velocity shows only satisfactory values for each conduit of the simple network in the considered sample. From the minimum peak velocity column, instead, it is easy to see that all the value are fully satisfactory respect to the minimum velocity 0.7 meters per second, except the conduit 11 to 9. We then should do something in order to fix that value as, for example, we could try to augment the gradient of the conduit. Let us suppose to be in a preliminary stage and that our goal is represented to get a preliminary sewer sizing. Under those hypotheses, we can hold over the problem of the longitudinal layout fine-tuning and focus our activities on fixing the minimum peak velocity for the conduit 11 to 9. According with this goal, We can directly modify the slope of our conduit, varying his gradient from 0.5% to 1%. Don't forget to press the Modify button in order to save all the changes you do. Now, let us run again iDrawlix 2k18. From the tabular view of the report window, we now can verify that the slope changing of the conduit 11 to 9 fixed our trouble. Going on with our final results checking, now we can perceive that, for the conduit 3 to 5, in the column that shows the rate Y on H as the fullness ratio after the run, iDrawlix did found, as best fit cross-section, a DN1000. Unfortunately, this cross-section, even fits the rational model calculated flow rate, shows clearly an unsatisfactory degree of fullness, which is greater than the recommended threshold value of 75%. Also in this case we should do something in order to ensure to our design the desired degree of confidence. We can try for example to choose a greater cross-section. Let us open again the conduit archive window. Let us select the conduit 3 to 5 and let us impose to consider, for the current conduit, at least a cross-section equal to a DN1100. Notice that if we lock such a cross-section, we are telling to iDrawlix 2k18 to consider always and in any case a DN1100. If the cross-section button lock is in the unlocked state, then iDrawlix 2k18 will choose a cross-section at least equal to a DN1100. Do not forget to press the Modify button, as after each parameter changing. Now let us run again the ASCE rain model. We can see that now the conduit 3 to 5 shows a fullness ratio that finally fulfill the threshold value. Okay guys, our webinar with iDrawlix 2k18 is gone. Thanks for your precious attention. We will see soon, with the next iDrawlix 2k18 webinar. Visit us on iDrawlix.com.